Hello, I am Shinita. I have done my internship with Emertxe in the domain of Internet of Things, in which I have implemented the project of home automation system. So before going into the project, I would like to summarize a bit about the internship program, what it taught me, and what and all it has covered and explained me. So going into the PPT. So the contents are learnings from this internship, introduction to C and C++, then Internet of Things, embedded system, then about the project, project requirement, project implementation, output, and the conclusion. So first the learnings. So in this project we have learned about the basic concepts of C programming, because C programming is needed for the coding part of the embedded system. That is the main programming language which is used. Then object oriented programming concept using C++ programming language. So because C doesn't support object oriented programming, so we are using the extended version of C, that is C++, for the programming purpose. Then as it is an IoT project, so a bit introduction about IoT, the Internet of Things, the different stages of IoT and the architecture. Then embedded system, yeah, exactly as it is embedded. Internet of Things works with the embedded system, so a little bit introduction about that. And then working with the Arduino, PixSimLab simulator and Blink IoT app. So since this is a simulator project we are doing, so all the things we are implementing uh, in a simulator using the Arduino ID, the PixSimLab, that is a simulator in which all the devices are connected and run, and the Blink IoT app, which is used to control the devices via the mobile app. So introduction about C and C++. So yeah, as I told before, we are using C because C programming language is the main language which we are using for development of the code for Internet of Things implementation. So we are using C because it is a general purpose language and it is used to develop softwares like operating system, database, compilers, and many more. And C++ is an extended version of C, or we can say enhancement of C, and which includes which includes object oriented programming, because C doesn't have object oriented programming, so we are using C++. And object oriented programming is used because it allows the developers to create classes and objects and define methods and properties which are needed for a secure and secure implementation of the code. Going ahead, okay, then we have Internet of Things. Okay, so Internet of Things, the basic definition is the interconnection of physical devices, which includes anything like car to mobile app, or a door, or lights, or anything which are inside the home that can be interconnected with each other and can be operated using a mobile app. So here it is written that it refers to interconnectedness of physical devices like such as appliances and vehicles, and they are embedded with software, sensors, and sensors are used because they have to sense the data from the devices and then they have to transfer the data. So the connectivity is used for transferring the data from the devices to the app, which enables these objects to connect and exchange data. So this technology allows for collection and sharing of data from vast networks of devices. Yeah, so we can connect as many devices as we can, and we can interconnect these data also, so that we get lots of data and we can give an accurate result to the user. Okay, then we have the stages of IoT. So the various stages of IoT include, first is sensors and actuators. So what happen in sensors and actuators is sensors and actuators are connected device they're connected to device to monitor and control the physical process. Okay, like sensors captures the process status and the like humidity, temperature, flow control pipeline, fluid level in tank, etc. And this condition data requires an immediate response for this. So for that immediate response, actuators carry the real-time remediation action. So next step is gateways and data acquisition system. So in this stage, what happens is data is sent by the sensor, is controlled by the data acquisition system and converted to into digital format. Yeah, because the data which we are gathering is in analog format, and we want that because device understand that in digital format, so we want that in digital format. So in data acquisition system, um, the the data which they have collected, they convert that to digital format. Then this data acquisition system, they will aggregate and format data before it sends to the internet gateway such as wireless LAN, WAN, etc. So this was second stage. Next stage is edge IT data processing. So in this stage, what happens is the IoT data that has been digitalized, means that has been converted from analog to digital, that undergoes further processing before reaching the cloud center. So in this stage, they basically do more processing of the data, and then they send it to clouds. Then next stage is the last stage is data center and cloud. So data center and cloud, they carry out in-depth processing with the help of high-end application design and run the skilled analysis by professionals. So they manage and store data in cloud and corporate data centers. So this is all things happen in the stages of IoT. Okay. Next we have layers of IoT architecture. So first layer is physical layer. So in physical layer, the physical layer of the IoT architecture basically includes the devices and the sensors that are collected that collect data from the physical environment. So this is about physical layer. This layer can include like anything like from a LED light to smart refrigerator to fitness tracker, the watch, smartwatches, etc. These are the physical devices layers. Next is network layer, or the network layer is also called IoT gateway layer. So in this network layer of IoT architecture enables communication between the device and the cloud. So this is about this layer. It acts as a gateway between the device and the cloud. So this is the network layer. The next layer is middleware layer. So in middleware layer architecture, it provides a communication between the devices and the application layer. So the device and the application layer, this middleware layer provides a communication between the two. The next is next layer is application layer, or this is also called platform layer. So application layer of IoT architecture consists of application that uses data controlled from devices. So whatever data is collected from the devices, it takes the data and processes and improves the decision making. So this is all about the layers of the architecture. Okay, next we have embedded system. So embedded system is basically an integrated system that is formed by combination of computer hardware and software for specific function. So it is made up of either computer hardware or software to perform certain tasks. So it is a dedicated computer, but it is developed to perform a particular task. Like a normal computer, it cannot perform different tasks. Like if it is dedicated only for sensing temperature, it will only do the temperature sensing thing. It will not do controlling lights thing like that. It is not a traditional computer, it is a general purpose computer, and these systems work with or without human intervention, like either human interference is required or not required, they will work. Okay, next now we go into the project. So a little description about the project, that what we have implemented in the project, like what is the aim of the project. So this is a home automation system that has the ability to do tasks automatically and monitor or change status remotely. So in this project, the common tasks include is turning off and on the garden lights, like controlling the lights, temperature of the home, controlling like measuring the temperature of the home and controlling the temperature also. Then inflow and outflow of water in the water tank. So if the water tank is full and if it is empty, then accordingly we will on and off the water tank. So this project is implemented using a PixSim Lab simulator and controlled using Blink IoT mobile app. So some description about the project is, okay, so before we go into project requirement, some description about the project is, we use different peripherals like some description about the requirement of project is, we use different peripherals like Arduino IDE for writing the code, writing the C programming language code and implementing it. Then PixSim Lab simulator, yeah, as we said, we will implement it using a simulator, not a real hardware object. So simulator includes LED, LDR sensor, temperature sensor, then PCF8574, ETHW5500, LCD HD44780 and Arduino Uno, then Blink IoT app, then null emulator. So the requirements of the project include, first, as we are implementing three things, in which the first thing is garden light control. So in this we read the sensor value, and based on the reading we vary the brightness of the LED. Suppose if it is sunny outside, then the brightness of the LED will be dim, and if the brightness is dark, like if there is no brightness, it is dark outside, so the LED's brightness will be high. So this is how we are varying the LED sensor value, LDR sensor value. So the input to this is LDR sensor and output is garden lights on dim or high according to the environment condition. So this is how in the LDR sensor will sense, it will send to the Arduino Uno, and then it will display the output in form of the brightness of the light. Next we have temperature control system. So second thing which we are implementing is temperature control, to control the temperature and to vary the temperature according to the requirements. So it consists of a heating resistor, LM35 temperature sensor and a cooler. The cooler resembles the temperature control system of the home, like cooler and heater, they resemble same as the temperature control system as it is in our home. So what it does, it reads the temperature LM35 and display it on CLCD. CLCD is a screen on which it displays whether how much is the temperature for understanding of the user. Then we control the temperature using on and off button of heater and cooler from the Blink IoT app. So input is the temperature which it reads from the environment, and display the temperature on gauge. It will display on the gauge and also it will display on the CLCD. So this is the diagrammatic representation. First it will sense the temperature, it will transfer the value to the Uno, then the Uno will transfer it to the Blink cloud, from which the Blink IoT app will access the data and display the output. Same way CLCD will display the output. And the third requirement for this project is the water tank inlet and outer valve control. So in this we read the volume of the water in the tank, through a serial communication and display it on CLCD. And then we control the volume of water in the tank by controlling the inlet and outlet valve by sending the commands through serial communication. So we display the volume of the tank on the CLCD device. So the input is the serial tank volume, whatever it is taking, and display the volume of water on the gauge and display the volume on the CLCD also. So this is the diagrammatic representation. It will read the value from the water tank, the volume of the water, then Arduino Uno, it will pass to the Arduino Uno, then Arduino Uno will pass it to the Blink IoT app via the cloud. Then Blink IoT app will display the required result to the user, and same way required result will be displayed on CLCD. Okay, last is Blink application user interface for controlling. As we said, we will be controlling the devices through the mobile app. So whatever controls we are doing, that is done using the on and off button in the mobile app. So the Blink is designed for Internet of Things. It controls hardware remotely, and it can display sensor data and store data, visualize it, and do many other cool things. So in this video we create widgets for button to control heater, cooler, inlet valve and outlet valve. We create on and off button for all these four. Then we create a gauge widget. Gauge widget displays the temperature and volume of the water tank on the mobile app. And last is the terminal widget, which displays the notification whenever the threshold is crossed, and accordingly whenever there is a need to display the notification. Okay, project implementation. So this is the diagrammatic representation. First it reads the value, sends it to the cloud. Blink cloud sends the data to the mobile app, and the mobile app displays gives the desired result according to the user requirement. So in this project we connect different appliances like garden lights, heater and cooler for temperature sensor, and serial water tank using Blink IoT app. All the data are sent from the individual devices to the Blink cloud, from where the data is accessed by the app and then accordingly displayed to the user. In this project, all the devices which are used in the home appliances are virtually implemented using the Pixum simulator. So this is the first output. In this this is a temperature. T represents the temperature, V represents the volume, and the letters after temperature represent whether cooler is on, or this is cooler status, and the letters after volume represent the tank status. So in here the temperature is 27 degrees Celsius, and the volume of the cereal tank is 1770, and the status of the cooler is on, and the status of the cereal tank is its inflow is on. So means this is the inflow, the water is entering the tank. And this is the LED display through the LDR. As we vary this thing, as we go down, like as we decrease it, the LED will be dimmer, and as we increase this, the LED will be brighter. So this is first output screen. Then this is a second output screen in which the cooler is off and the inflow is off. So as you can see, now the tank is full, so the inflow is off and cooler is also off. This is the cooler, and the temperature and volume are accordingly displayed. Then this is the third output in which the heater is on. So heater is on, so temperature was varied. Then this is the volume. So as the outflow is on, see, this is the outflow, water is flowing down and the volume of this tank is decreased. Next output is when heater and outflow both are off. So here the heater is off, so the temperature is this much and the volume is 0 because of the entire tank is empty and the outflow is also off, the no water is going out here. Okay, this is the Blink app interface, in which first the cooler is on, then the cooler is off. First the cooler is on and inlet valve is on, and cooler is off, inlet valve is off, and this is the gauge which displays the volume. This is the gauge which displays the temperature. This is the second interface, which shows when the heater is on, outlet is on, the gauge displaying temperature, gauge displaying volume. Then when heater is off, temperature is off, gauge displaying the sensor temperatures. And okay, this one gauge displaying. This one is the notification panel, which shows when the threshold is met, like turning off the heater because the threshold value of 35 degree has met. So when that reaches the temperature, the heater turns off automatically. So this is the notification panel. So conclusion from this I would like to derive is that using Blink IoT app and PixSim simulator, we can easily simulate the home automation app remotely and understand how it works at main real-time level. So this activity, this project helped me understand how at small scale we can understand how we can implement it on large scale, where LED temperature system, serial tank, which resembles the light, heater, cooler and water in real time, and CLCD it acts like a dashboard used for displaying the result. The widgets from the Blink IoT app, like button used to control heater, cooler, inlet valve, and gauge widget is used to display the temperature and the volume. So thank you. Now I would like to show the demo of the project. Okay, so now coming to the demo part of the project. So this is the Arduino IDE in which we have written all the codes for implementing the project. So this tab ldr.cpp, in this we implement the garden lights on and off condition. So we have declared all the functions to do the same. Then ldr.h we declare all the macros for the sensor button so that it is easy to use in the main program code. Then this serial tank has again the functions for inlet and outlet and enable inlet volume. All those functions are written here, which will be called in the main CPP file. Then we have serial tank.h, in which again we have declared all the macros and also we have declared the functions. Then we have temperature.cpp, in which again we have declared the variable we have declared the functions, and then we have implemented some of the functions function code inside here. And then temperature system, again in this also we have defined some macros and the functions. Then comes the home automation Blink, in which we have called all the functions and used it here, which this main function is used to this main code is used for implementation of the whole project. So when we compile and run this, it will take all the functions and their variables which were declared in the individual file, and it will call that, and this will run the project. So this is all about the code. Then now we'll sketch, export, compile binary. We'll compile the code. Yes, so the code is compiled. Now we'll go to PixSim simulator. We will load the file, load hex file. Yeah, so it is loaded. Now we'll open So this is the Pixem simulator and this is serial tank. So here this one is the screen, the component which has a screen. This is called CLCD, this in which there are so many LEDs. This is the LED to display the brightness. This is LDR for varying the brightness. This is W5500 and this is a cooler sensor in cooler and heater, which will sense the temperature, and according to that it will display the output. So this is about the Pixim Lab simulator components which we have used. Then here is the serial port, which is similar to the water tank. Here this is the inlet valve, then this is the outlet valve. The water will enter from here and water will exit from here. Now I'll show you the implementation. So implementation we are doing using Blink IoT app. So I'll open the app. Okay, so this is the screen for Blink IoT app. So first we will turn on the cooler. So I have on the button. See, you can see the fan is rotating and here it is displaying cooler on, and since this is a minimum temperature below which it cannot go, so it is not varying, there is no variation in any temperature. Now we'll off the cooler. So here the output is cooler is off and the cooler is off. Now we'll on the heater. So we can see a heater is on and we can see the temperature rise. So we'll keep seeing the temperature rise, and here in gauge also we can see the rise in temperature. And see, as the temperature has reached the threshold, so here it is displaying temperature of 35, so we'll turn off automatically. The heater is turned off and here also the button is off, and the temperature is slowly decreasing to the normal temperature of the component. Then yeah, this is for varying the light. So this LED light, as we decrease the value, we can see the brightness is also decreasing, and as we increase, the brightness increases. So this was about LDR, the LED and the cooler for the temperature sensor. Now we'll go to the serial tank. For serial tank, we'll first on the inlet valve. So we can see that the water is filling the tank, and here in gauge also it is displaying that the water is filling and how much volume it has filled, and the maximum temperature, maximum volume it can hold is 3000 liters. So it is filling. We can stop it at any time, there's no problem. So I have stopped it. Again we can on, it will continue from there. Okay, so water is automatically now filled, so the inlet valve automatically gets turned off. Now we will turn on the outlet valve. So we can see here that the water is flowing out and the volume is also decreasing. It is displayed in the gauge also. So we can see a notification here that the tank was full when the inlet valve completely filled the tank. So the inlet they off the inlet valve. So this notification is displayed here. Now we see the volume here, so it is decreasing. Yeah, it's completely empty. Now we'll see the message here. So turning off the, okay, there's no message here. Okay, so this was the project. So with this project we could easily see how using mobile app we can easily implement our home devices. We can easily control it from anywhere, just giving certain inputs to the device and taking the inputs from the device. So this was the project. Thank you for giving me the opportunity to perform this project, and thank you for all the knowledge. Thank you.